Once more again, we continue. Now, check on your screen. Let's read this exercise. If you can check, it's the same as this one. You can see it says 16.1. The follow-up is 16.2, somewhere here, 16.2. I just cut it out to make space. So, let's read this part where I am hovering. Okay, let me just do this. Okay. Alright, let's read this part. This part. There we go. So, okay. They say if the following information is applicable to the above circuit. So this part, the way I've highlighted, it's 16.2 from the textbook that I took it from. So they are saying if the following information is applicable to the above circuit, right, then they tell you the value of the capacitor is 120 microfarads, load resistor is how much? 50 milliamperes. Then they say to you, calculate the output DC voltage. So this is basically what we are having. So you're supposed to calculate for two things. Yeah, before I continue, let me just go and make copy and paste of formulae. There we go. I'm just gonna do this. Okay, I'm just gonna make a copy and paste. Cool. Why so huge? Okay, I'm trying to do this. Cool. There we go. So, right now, we were given a circuit where there was no filtering. You saw the calculation. Alright, if you didn't see it, go to part 2. This one, that says part 2. But right now, okay, sorry for scrolling up and down. Right now, we are on part 3. We are dealing with filtering. I showed you earlier on the previous one what filtering does. It changes this waveform. It changes this waveform into this type of waveform. That's what filtering does. Alright, it happens around C1. That's what happens. So let's continue. The formula that we're going to use are the one that I just posted here. Okay, the formulas. Kids, all of these are the formulae that we're going to use. Alright, so first of all, they say calculate output DC voltage. Now let's backtrack a little bit. I'm gonna scroll upwards. Output DC voltage, if you do not have a capacitor with a value, this is how you calculate VDC. But because now we have VDC, we do have a capacitor listed. Key here, there's a capacitor. Alright, now we're going to do what? We're going to use these formulae. Let me just zoom out a little bit. Cool. There we go. So the formula that we are giving in this case is VDC equals to V peak minus IDC over what? 2FC. Now let's calculate. Right, let's continue. There's something that is wrong. I'll tell you what. Okay, something is wrong here. Let's read the statement. The statement does tell you that it is a the statement tells you that this is a full wave bridge rectifier. So since it's full wave bridge rectifier, right, we need to also change this. This needs to be changed. Alright, if it's a full wave, you will have to square it by implementing 2 squared, which makes it a 4. The formula sheet is given to you as half wave. So therefore, if it's a full wave, you need to square the 2 and make it a 4. So therefore, when we do this, when we redo it, it's going to be VDC equals to VPIC minus IDC over 4FC. Why for FC? Because the circuit is a full wave. If it was a half wave, we will leave the formula as 2. Now let's substitute. Do we have V peak? Now I'm going to scroll upwards to get my V peak. My V peak in this case, it was 35.361. So that's my V peak. Alright, 35.361 minus, what is IDC? IDC is your load current.